Hey, this is me Geek and I'm Dan. Welcome back to the channel. This is the Robot Cameraman Mark II. I've been promising a bit more of a proper video about updates and this is it. A little bit of history, I guess, if you don't know, if you've not been following the channel. A long time ago now I built a robot for my camera. It started as just like a 2-axis gimbal and then it added a crane and I slowly added more and more features over time, and there are various videos about it on my channel. But it was all a bit precarious, still is precarious, and I've been meaning to do something about it for a while, improve it, upgrade it. I've had various thoughts, and then a few weeks ago I was moving it in the workshop, and one of the things I've been meaning to fix is to make it more stable, and it wasn't, and it fell over and it sheared a bunch of mount plates in the 3D printed gimbal and took it out of action. So I thought, you know what, that's it, that's the trigger, it's time to upgrade it. And what you see here is the first stage already kind of rebuilt and upgraded, and we'll talk a little bit about what that is. In theory, it is now back in action and able to move. It's got a little bit of a fuller range of movement than the old version, but until I add another axis, it's also more limited in other ways. We do have the ability to trigger the recording again, so hello this camera, and obviously the waypoints and everything still works the way it used to, and I can control the zoom now with a servo motor. This used to be a belt to a stepper motor. The problem with that was that the belt put a lot of sideways tension on the lens and like wanted to drag the camera across. I was never super happy with it, and obviously it's harder to kind of have absolute positioning. Well, it's not harder, it's like it's a different way of doing absolute positioning, whereas a servo basically gives me control within the range pretty reliably, much as before, but I can do almost the whole range of zoom, not entirely. I need to tweak that. But there we are. So we're sort of back to a point where it can move, and it can follow certain instructions. I have a bunch of glitches in the software which I need to figure out, which I think are a factor of having moved this onto the servo, controlling the record button actuator, and some other things which we'll get to. For now, let's bring you in a bit closer. I'll talk through what I've done so far, and then we'll talk a bit more about the plans. Alright, so objective. I kind of want to make a full 6 degrees of freedom robot arm. It's been on my mind for a while. It's a bit ambitious. It may not work. There's obviously a lot more challenges to a robot arm that has potentially more reach. There's a lot more torque at play. I kind of overcame a lot of that with the crane being counterbalanced. I may still be able to get away with some counterbalancing in a robot arm, but with more degrees of freedom, more complicated. There's a lot more complicated control software requirements. That's ultimate goal. Intermediary goals obviously was to bring the robot cameraman back into functionality, but what I wanted to do was basically start from this end and work back towards the hub, rebuilding it, with the idea being that at various junction points I would kind of get to somewhat stable points of functionality, but also by starting from the payload end, like this is the non-negotiable. I wanted to carry this camera and be able to move this camera reliably. If I messed up a junction such that it wasn't strong enough or reliable enough, then like I could kind of redesign that until it worked before moving on. Whereas if I came the other way, I might get a long way down the build and then find out, you know what, like this design doesn't have enough torque to move a thing, and it might be more of a pain. So that's why we started here, with literally an aluminium plate to mount the camera on, mounting through the standard tripod mount at the bottom, and this gave me the opportunity to mount the servo to drive the zoom motor. So this is kind of inspired by the fact that you can buy very expensive and overpriced zoom controllers for Canon cameras, which are a little module that clips it right here and does exactly this, right? Like it's just a servo drive thing. So cheap servo, ESP32 to drive it, a little mount point, golden. So that's there's probably more I can do to finesse that, but for now that's pretty good. And as I mentioned earlier, like the absolute positioning thing with a stepper motor, obviously you can control precise movements, but wherever you initialize it, you don't know where you were, and so you need like another sensor if you need to figure out how far in or out you were. Whereas with a servo, like 0 degrees on servo is always going to be a certain point in the path, and so I can always initialize to a location of fully zoomed out, and it always knows exactly where that's going to be, which is kind of convenient compared to using the stepper motor. So that's your base plate. Then we have a couple of risers on either side that are scoped to go around the camera. Let me just move this around so you can come this way. So just a bracket here and a bracket here. The other thing that kind of used to bug me about the gimbal arrangement that I had was that the gimbal itself blocked access to the ports. So on this side where you have your SD card slots, I wanted to be able to very easily get into that, and on the other side, obviously you've got all of your ports for HDMI and all that kind of stuff, and this was always just really fiddly to get to, and I kind of never could use the screen either. Whether or not I will use the screen, I don't know, but it's convenient to have the ability to bring that into play again. I don't currently have the HDMI cable plugged in, which I used to use to display what the camera could see on a big monitor, and part of that is that when it fell over, that cable got absolutely mashed. So that then just brings us up to a top bracket, and the top bracket provides a mount point for this little 3D printed thing, which holds the servo in front of where the shutter button is, so that can drive the record and stop recording just like that. And for the moment, I can't remember why I did this, but I have it set so you can only hit record once every 30 seconds. I feel like I can reduce that latency because it's kind of annoying. But anyway, and for the moment I have the mic clipped. So that is all of the, and obviously I don't necessarily use it, but I can do a full 360 turn now because of this 3D printed assembly, which encompasses, let me just grab one. Encompasses one of these big bearings. So I basically 3D printed a 2-part outer which clamps around the outside ring and a 2-part inner that clamps around the inside ring, and that 2-part inner has a hole through the middle for all of these cables to come up and through, and then on the top holder here there's a internal cog ring. Let's go look at that. So it's not super easy to see here because it's all black on black on black. These are obviously all the wires coming up from the servos, but you see here this is the internal cogged ring of going through that internal race of the bearing, and obviously we have the stepper motor here. So this is mounted on a bracket and obviously has an internal drive cog that just rusts against the inside of that. Boom, spins. So that is pretty nice. It gives me full 360 turn and the ability to just have all the cables come through the middle, which is a lot neater. And yeah, that I think is so far pretty good. However, this does present a challenge. I'll come back to the challenge in a minute. So this brings us to the tilt axis. So as you could see, if I just bring this over here a bit. So there's a big cogged gear on each side of this piece that presents a little nubbin through a bearing which is mounted into this aluminium arm, and that wrapped around that is a GT2 3mm timing belt. So you can see it on this side as well. That belt runs through this, like, this is really just a stretcher spacer, but it kind of provides a little bit of a tensioner point as well, which is quite convenient. And it goes through to you can see there are little pulleys on this axle right here. So this is just a piece of 10mm steel with an 8mm recess on each side to go through a standard skateboard bearing, which is also milled halfway into this arm and then half retained by this 3D printed cap. So from this side you can kind of get a better view of, this is obviously the tilt motor, which is mounted near the back of this element. One thing I'm obviously conscious of as I build this is the more weight out here, the harder everything gets. So anytime I can sort of bring a certain amount of weight back towards the core, the better off I am. I don't know how much difference it will make in the long run, but that's the theory. So at the moment, this motor is just mounted on a 3D printed bracket that kind of screws into this plate and obviously drives this big cog. And I was worried when I originally designed this, because at some point you have the camera like fully out, maximum torque, and the camera itself is, I think it's about 3 kilos including the aluminium and whatever, so it's not a lightweight thing. But this holds great. It's a fairly rugged thing. The only concern I have, which may be a problem over time, is that the axles that go through here are 3D printed, and any torque is on layer lines, which is a bit sketchy. So if there's too much pressure there, that could shear. But that brings me to one of the concepts, so grandiose. One of the theories I had, which you'll have noticed, is that some of these parts are 3D printed and some of them are aluminium that I have milled. And kind of what I had in mind was that as far as possible, I would be able to prototype in 3D printing and then manufacture in aluminium where it made sense to do that. So some of these parts that are 3D printed may become aluminium milled, some of them won't. The gears are probably the big exception. I've had great success with these on the robot cameraman for a long time, so I'm not too worried about these. But obviously, like, I bought real pulleys. I could machine a real aluminium crossmember here. Some of the structure that wraps around the bearing over here will be aluminium, could be aluminium. This doesn't really matter, but it will matter more coming the other way. Obviously, aluminium arms for strength and all the bearings that make these axles are recessed half into the aluminium, but then just a 3D printed cap just to hold it, kind of retain it. I think it'll be fine. So we'll see how we get on, but that's kind of why parts of this are metal and parts of this are printed. And I say, so far, I'm pretty happy with its ability to handle the torque required to move it reliably across the two axes that I've got. Alright, so let's talk about benefits and challenges. One of the things I wanted to be able to achieve was the ability to actually point the camera straight down when necessary. So in this case, I have it pointing at my hands, which shows me using the controller. And that is cool, although it is also really not focused. Oh, because I had the focus box in a really weird location. Why is it over there? I wanted this thing to be able to point straight down, potentially, like hover over machines. I often have this problem, obviously, if I'm trying to get good shots on like the lathe or even just on the workbench. You're limited with the gimbal. I could only ever get a certain angle. So this was an important measure of what I wanted to achieve. However, this, for the moment, I mentioned earlier, comes with some challenges itself. So, sorry, it's difficult to talk and use the controller at the same time. So, one of those challenges is that previously I had the tilt was basically mounted inside the rotate, and the tilt was centered on the camera. So if I'm standing straight in front of this, you kind of get the idea that this is fine. I can tilt it up and down. That's great. But if I'm standing over here, now tilt rocks it off to one side, so it's all all skewed, which is, you know, fun in the horror movies to try and indicate something that is off kilter, less so in a YouTube video. So for now that's a problem, but obviously when I add another rotation axis, the idea is the next rotation axis should be able to offset that, although it will probably create another element of issue where it will kind of shift it laterally, but then the next axis will help me adjust for that, etc., etc. So it's kind of, this idea of a 6 degrees of freedom robot is cool, but as mentioned, it adds a lot of complexity to control. So at some point I will need to get into doing probably inverse kinematics. If you're watching a video this long about robots, you probably know what inverse kinematics are. I have no idea how to set that up at the moment. I've done a little bit of looking and I've found so far it to be way more complicated to even get the basic software up and running, to even start thinking about it, than I would have thought. So I might see how far I can drive my own control software, but at some point I probably am going to want to be able to drive specifically what I want to happen to the camera lens and have it figure out the rest of the actions, whereas at the moment I am controlling all of the axes manually. So the other thing that I would like to get to is, at the moment, pretty clearly there's some rock in this. Doesn't matter most of the time. A lot of the time I move the camera, I leave it in a place whilst I record, and if I'm doing shots whilst it's moving, I can kind of smooth that out in post. So it's not a huge issue, but it would be nice to get to a point where everything is a lot more rugged and locked down. But that's probably going to be quite a long-term project. So what's next? So right now, as part of my principle of keeping things working through the stages, this new aluminium construction kind of ends here, and essentially the old robot is here, and temporarily I have welded a steel plate on for this to bolt together. This is obviously not long term. In theory, the next axis will bolt here instead. So I mentioned these guys. So I have another one of these because ultimately this bolt pattern is designed to fit on the interior space of one of these. So the next plan, let's take a look at the mill. The next plan is to manufacture a clamp enclosure, much like I did with the 3D printed, but now in aluminium. Now you'll see that this is a hot mess at the moment. If you saw my Instagram reels, I decided to cut the rough center out with the plasma torch, which was really pushing my luck with the plasma torch, but just because then I could save that interior chunk as opposed to just completely melting it away on the cutting it away with the boring head. But it is it's comfortably within margin. Ultimately I need to create a recess for the exterior edge of this that will get clamped between these two panels when they're all cleaned up and beautiful. And then these panels will provide hopefully a robust clamping position to hold on to whilst the rest of that arm is on a swivel inside of that. I don't know if these ultimately are going to be good enough. They're pretty rugged, like they're very strong feeling, but obviously I'm going to end up putting a lot of torsional forces across the bearings, and I may find that this can't take it, or something else needs to happen. I have a few ideas for how I could strengthen it if I'm finding that it is on the edge. But obviously part of this is, how expensive is this project, Dan? How much am I spending? So as an example, each one of these was £14. So far I have two. This chunk of aluminium, this size, was about another £12 each. Actually, it was about 23 quid for the pair. So that's like £37 just to begin to create something which I think is strong enough to hold the next axis. which in terms of industrial 6-axis robots is not a lot of money. In terms of me messing around on something that might utterly fail, it's quite a lot of money. But you know, this is why I was keen to construct this in a path in which I kind of get back to functional at various stages. So if I need to leave it aside for a while, or if the next bit goes horribly wrong, I'm not too committed. I don't have to get the whole thing. I could use it like this. It would be nice to sort the skew angle aspect out by having another axis. But there you go. That's where we are right now. I appreciate I did almost all of the interesting actual making stuff. Not exactly off camera. If you follow me on Instagram or TikTok, you probably saw bits and bobs of it as I go. I did put out a couple of shorts, but I kind of wanted to just get the feet back under me, as it were, to understand whether or not this was going to work. And now that it's starting to come together, it's a little bit easier to put some videos out about it. So probably the next thing will be taking those horrifically plasma cut plates, figuring out a holding mechanism, you know, how exactly I'm going to mount them on the mill to clean up the edges and bore that center out properly. So that's probably the next big thing. We'll be manufacturing that, which I'll do in the next part. For now, if you have any questions, drop them in the comments below. If you think I'm a madman for trying to do this completely custom when there are lots of open source designs and proven projects out there, yeah, I know. I don't know what it is that makes me want to just kind of do it myself from the ground up. But that's part of the enjoyment, right? Like, it's me messing around, designing stuff in CAD and manufacturing it myself. So, I know there are lots of great options out there. I'm not saying that they aren't there or that they aren't great, but I guess I have a very specific use case which I'm keen to chase, and I'm enjoying doing the design. The other thing I will say, small observation, maybe it's just me, but I've seen many videos on YouTube of people who make robot arms, or indeed robot cameraman. I've seen a couple of people who do them. I haven't seen many videos after that where they actually use those things to do something. I will say that if you look back at my videos, once I built the robot cameraman, it featured quite heavily in the production of future videos, at least in motion shots and all that kind of stuff. So I do have a real use case that I'm kind of driving towards that hopefully will see the benefit of me spending this money and time. But there you go. Anyway, enough blab. Thank you for watching if you watched this far. Let me know in the comments if you think you have any ideas for how I should progress, or any sources for cheaper bearings parts that will take the load. Yes, I am also working on a planetary gearbox because I don't think the next set of stages will work straight off the motor gearing. Maybe I'll do another video about the planetary gearbox design, which I'm also designing myself. Anyway, thanks for watching. See you next time.